In this video, we're going to take a look first at the sum and difference identities and how to use that to find the exact value for angles that were not part of our first quadrant or reference angle situation. So I'm just going to add in here, find the exact value of each. And then off to the side, I'm just going to write some steps of what we're doing. So 15 degrees is not one of our three angles, our 30, 45, and 60, but we want to find two angles whose sum or difference give us that 15 degrees from our set. So what you always want to look for is how can you use 45, 30, and 60. We have two options for this first step. We can do 45 degrees minus 30. That gives us 15. Or we could use 60 minus 45. The common denominator here is a lot of times that we're using a 45-degree angle as one of our angles. I'm just going to draw a line to block off the steps here. Okay, so then we're going to pick one of these. It really doesn't matter which one. I'm going to go with the first one and do sine of 45 minus 30. Once we've picked the one we want to use, we're going to identify the correct sum and difference identity and then fill in the angles. So in this case, and this isn't something you necessarily need to write out, this is something more you can think about. This would be sine of A minus B is equal to sine A cosine B minus cosine A sine B. I think most of the time as you're writing that out, you'll probably fill the angle in. So our third step, second and third, you'll kind of probably do together, is to fill the angles into the formula. Making this sine 45 cosine 30 minus cosine 45 sine 30. I'm actually going to revisit that. Give myself a little more space to fit that in there. All right, fourth step, evaluate using exact values. So this is going to take us back to our first unit. And you are going to have to worry about the quadrants and those different things. The good news is this will be on a separate test than the actual identities test, but it's still kind of part of this unit. So sine 45 is root 2 over 2. These are all first quadrant angles, so everything is positive. Cosine of 30 is root 3 over 2. Cosine 45 is root 2 over 2. And sine of 30 is 1/2. So we'll evaluate, simplify. Then I always recommend to check your answers. You will have access to your graphing calculator for this. So after you've done this calculation and simplified it into root 6 minus root 2 over 4, you can plug in this original into the calculator and your answer into the calculator and see if the decimals match. If the decimals match but your signs are wrong, then it's probably that you messed up your signs here, and then you have to fix something. If the decimals don't match at all, then you might have messed up multiple signs or the exact values in a certain spot. In fact, just going to take a moment to open my calculator. And I'll put this back on the same space here so you can see everything. So if you head over to the calculator and just make sure you're in degree mode, which I am, plug in sine 15, and then plug in, you can even use your alpha y equals root 6 minus root 2 over 4. And they come out to be identical, so there's a nice way that you can check your answers here. All right, we're going to just do 2 more examples. I'm not going to rewrite the steps in these examples. We'll do 1 more with degrees and then also 1 with radians. So our second one is going to be cosine 165. Now my best option for this is go to the side, take 165, and subtract off 45. Because 45 is usually one of your angles, and then you'll get an angle that you're familiar with. If you subtract that, we get 120. 120 has a reference angle of 60 and is in quadrant 2. So it will help us later when we're figuring out positive and negative. But when you do that, you can then break the 165 apart into 120 plus 45 or 45 plus 120. The order should not matter. I ended up going with this order, but it doesn't matter which one you're working with. So if you follow our steps from above, we've now split it into our 2 angles. And there's other combinations that could work here. And then I'm going to use my cosine sum formula. Cosine of A plus B equals cosine A cosine B minus sine A sine B. Again, if you want to go right into filling the angles in this step, you totally can do that. So it'll be cosine 120, cosine 45, minus sine 120, sine 45. Now in quadrant 2, all students take calculus. I'm going to do a small little thing here off to the side. Sine is positive, cosine is negative. So when we're evaluating, we're going to get a negative here, but a positive on the other side. Reference angle is 60, so cosine will be negative 1/2. And then cosine 45 is root 2 over 2 again, minus sine of 120 will be positive root 3 over 2. So we're just going to fill it in exactly like that. It is subtraction in the formula. So if it were another negative, you would do a double negative, but the formula itself has the subtraction, so we keep the subtraction there. And then in this case, we're going to get negative root 2 minus root 6 over 4. Now that we have 2 answers under our belt here, notice they are very similar. Because we are using the same 3 values again, we get a lot of repeats in here. So the root 6, the root 2, and the divided by 4, if you're using sine or cosine, are going to be different combinations when you do the different combinations of angles. And that's not a coincidence. That should happen every time. I'm not going to check this one with my calculator, but remember, you can plug in the cosine 165 and the final answer to make sure that they come out to be the same. Now our last one, I'm going to do tangent and radians together. So it does make it a little challenging, which is okay. The best thing that you can do with tangent, and also with the radian measures, is think about pi over 4 as being a common denominator with this angle. So I want to make this a common denominator as 3 pi over 12. Then I can do the technique that I did in number 2. Take 19 pi over 12, subtract off the 3 pi over 12. Remember, pi over 4 is our equivalent to 45 in radian measures. If I subtract that off, I get 16 pi over 12, which simplifies into 4 pi over 3. So it's a nice result. And then again, we're going to be looking at this in terms of adding them together. But you do want to have it simplified because it's going to make things easier later on. So our reference angle here is pi over 3. And 4 pi over 3 is a little bigger than 3 pi over 3, so that's putting us in quadrant 3. Now I scrolled a little bit, but I have the all students take calculus up top for later on. And we are going to be working with tangent here. Tangent is positive in that quadrant, so that's helpful. Okay, so we're going to split this up and make this tangent of 4 pi over 3 plus pi over 4. And we're going to expand that using the tangent identity. So we're going to do tangent 4 pi over 3 plus tangent pi over 4 over 1 minus tangent 4 pi over 3 tangent pi over 4. Now in this one, I just went right into filling it in. I didn't write out the identity to start with. And then I will simplify this. So you'll end up getting a positive root 3 plus 1 over 1 minus root 3 times 1. Now, up to this point, we haven't needed to do any of this, but we will need to rationalize here. So for rationalizing, we want to multiply by the conjugate, which you've done a lot of this already in your identities. It might help to reverse the order of this top part right here. For doing that, I'm going to leave it as is right now. So I would get FOIL on the top, root 3 plus root 3 plus 1, and then plus 3, all over 1 minus 3. And then if we simplify this, we're going to get negative 2 minus root 3. This combination of the 2 and root 3 is going to show up multiple times when we're doing this. So I'm going to check this with my calculator. I would need to switch over to radian mode. There's another way that you could type this in, but I'm just going to go with that for now. So tangent 19 pi over 12. And then we're going to do negative 2 minus square root of 3. And it checks out because both of our answers come out the same. Okay, and that's the end of this video. The second one is going to take a look at finding the values using the triangles with the sum difference and also the double angle identities.